Hi there, everyone. This is intended to be a short demonstration on how an online tutoring session would potentially go. I have a notebook open here, and I have my uh, digital pen and paper ready to go. And so if we had a sample problem here, I would go through it with the student and ask about their understanding and work step by step towards a solution. So in this particular case, the nature of the problem is towards the end of high school, and it involves a rock that's dropped into a water well that travels approximately 16 t squared feet in t seconds. So if the splash is heard at 3.5 seconds later, and the speed of sound is 1,087 feet per second, what's the height of the well? So what I'd be able to do, first of all, is just draw out the situation. So in this case, you have a rock. There it is, that's your rock. And you have some water at the bottom. And you'd have a height. And if we call that x, you'd want to know what x is. So you have a rock that's falling into a well, and you want to know what the height is. So what do you know? Well, if you say that t1 is the time to splash, and you say that t2 is the time for the sound to travel back. Then the only thing you know for sure from this problem is that t1 plus t2 is 3.5. So in this case, we have t1, the time to splash, t2, the time for the sound of the splash to travel back up to where we were when we dropped the rock. We just know that if we add these two times together, it's 3.5. Why is it 3.5? Because we heard the splash 3.5 seconds later right here. Great. So now what? Well, what else do we know in the problem? Well, they told us that the rock is traveling approximately 16 t squared feet in t seconds. So we could say that the height, x, is 16 t1 squared. Why t1? So t1 is the time to splash right here. So I guess what we can try to figure out here is express the height x as a function of t1. So the time to splash here was 16 t1 squared because the rock travels approximately 16 t squares feet in t seconds. But we could also work the other way around. And since we know that the speed of sound is 1,087 feet per second, we could also say that x is equal to 1,087 times t2. So here we have two different expressions for x. So what does that mean? Well, we can solve for t1 and t2 in each of these. So for the first case, we would get t1 is equal to the square root of x over 16. And that's just the square root of x over 4, because the square root of 16 is 4. Then also, we can solve for t2 down here, and that's just x over 1087. So the key here is just to use everything that's given to you in the problem. We had the time uh, between when the rock is dropped and we hear the splash, and we also have the speed of the rock itself, or the distance that it travels in any given amount of time. And we also have the speed of sound. So using those, we were able, using each of those statements, we have a corresponding equation. So since we solve for t1 and t2, we can take this, plug it back into here, because we know these two quantities, when we add them together, should give 3.5, and we get the following. Square root of x over 4 plus x over 1087 is equal to 3.5. So this right here if you get this far, this is really where all the concepts come together. So this is a multi-step problem. This is not an easy, quick problem. But once you get this far, this is your equation to solve. And it becomes a quadratic equation that you can solve and find out the value of x. And so in an actual session, we would go further and we would turn this into a quadratic equation, and we can talk about what other ideas would lead to deducing all of the equations that you need to solve the problem. Every student sees things differently, so it helps to go step by step and make sure that each step makes sense. What's fun about the online tutoring system is that we have all the information laid out at all times, and we're not just looking at a piece of paper in front of us and one's reading it from upside down and one can't read it very well. This is a really sort of holistic approach to the teaching process. So I've had a lot of success with that, and I'm looking forward to more.